It's time to complete your second lab assignment. In this week's assignment, week 4, you will use your knowledge of the binomial probability distribution. You will also revisit what you have learned about basic descriptive statistics, like the mean and the standard deviation. Let's start by getting all of your materials open and ready. You will need each of the following items. You will need your week 4 answer template, the Minitab version, since this demo uses Minitab. You will need your lab data. It's the same set as you used in week 2. You will also need your Minitab software. You will either use the Minitab software on your computer if you have a PC and were able to download the trial version that I showed you, or you will access it via Citrix through the DeVry server. Once you have your lab template open, go ahead and save it to your computer by selecting the Save As option and using your last name, first name, and week 4 lab wording. It is very helpful to me if you save your file as the 97-2003 version, which is a .doc extension, as that is the most universally compatible when opening for grading. If you're using a Mac, it might say 97-2004. After you have saved your template, you are ready to begin working on your lab by simply reading through and following each set of instructions given one step at a time. I even recommend printing a copy so that you can highlight your steps and check them off as you go. Let's begin. Step 1 says to open a new Minitab worksheet. This means that you do not need to use your data set just yet. You are using a blank worksheet for this task. Open Minitab and you will have a blank worksheet right there in front of you, ready to use. Remember, as you watch this demo, I have changed numerical values and the data sets for demonstration purposes. Your actual instructions will have different values and will, therefore, give different results. This demonstration is to provide you with a good overview of how to complete each process skill. Let's read the second step in the instructions. We are interested in a binomial experiment with 15 trials. So before we go any further, let's revisit what a binomial experiment is. Recall that a binomial experiment has 4 very specific characteristics. In a binomial experiment, each trial must have a probability that's independent of all the other trials, so every trial must not impact the outcome of every other trial. Each trial must have only 2 outcomes, a success or a failure. There must be a fixed number of trials. In this case, we're saying we're only going to do 15 trials, no more, no less. And the probability must remain constant for each trial. Every trial must have the same probability of having a success or a failure. So in this particular trial, we're going to make the probability of a success 1/3. And we're going to use Minitab to calculate the probabilities for this distribution. We're going to figure out what the probability would be for 1 success, 2 successes, 3 successes, 4 successes, all the way up to 15 successes, and any cumulative amount within all 15 trials. So to set this up, in column C1, let's enter the word success as the variable name, and that's in the shaded cell above row 1. So now in that same column, enter the numbers 0 through 15 to represent all the possibilities for the number of successes. These numbers will end up in rows 1 through 16 in that first column. In column C2, enter the words 1/3 as the variable name. Pull up Calc, Probability Distributions, Binomial, and select the radio button that corresponds to probability. Now this column is going to hold all of our results for each individual probability. We're going to figure out if we have a probability of 1/3 for each of these, what's the probability for each trial, for trial number 1, 2, 3, 4, 5, all the way up to 15 to have a success. And this is how we tell Minitab to do that calculation. We enter 15 for the number of trials, and we enter 0.33 for the event probability. Now I know 1/3 has more 3's in it than just 2, but for this example I just used 0.33. For the input column, select success, and for the optional storage, select 1/3. Click the button OK, and the probabilities will be displayed in the worksheet. Now we will change the probability of a success to 2/3. So in column C3, enter the words 2/3 as your variable name. Use similar steps to that given above in order to calculate the probabilities for this column. The only difference is in event probability. Use 0.67, and for optional storage, select 2/3. Finally, we will change the probability of a success to 1/6. In column C4, enter the words 1/6 as the variable name. Again, use similar steps to that given above in order to calculate the probabilities for this column. The only difference is in event probability. Use 0.17, and for optional storage, select 1/6. Now that you have created your distribution for these binomial probabilities, you can create graphs to display them. Follow the steps outlined on the template to create the scatter plot directly in Minitab. Select Graph, Scatter Plot, and Simple. Then for Graph 1, set y equal to 1/3 and set x to success by clicking on the variable name and using the Select button below the list of variables. Since you have 3 distributions, you're going to make 3 graphs. A graph will represent each individual distribution. For Graph 2, set your y equal to 2/3. We will still be using x to represent your successes. So in Graph 2, once again, set x equal to success. For Graph 3, set y equal to 1/6 and x to success. Click OK to see your new graphs. You can now copy and paste those 3 scatter plots into the gray area that is provided in your template. You can just right-click and copy each graph and paste them one at a time. So now you're ready to move on to the next section of your lab, calculating descriptive statistics. Here is where you will use your data set. You will use the same class survey results that were entered into the Minitab worksheet for the Week 2 iLab assignment for question 2. You can open a new blank worksheet in Minitab and simply paste the data from Excel file into that worksheet. Open the new worksheet by clicking File, New, and then select Minitab Worksheet. Copy all of the columns in the Excel file containing the data, then place your cursor in the upper left cell of your new blank worksheet in Minitab. Right-click and select Paste Cells, or you can choose Paste Cells from the Edit menu. You will calculate the descriptive statistics for the variable coin, where each of the 20 students had flipped a coin 10 times. We know this must be a binomial experiment because it meets the 4 criteria we outlined previously, right? So in order to do this, we'll pull up Stat, Basic Statistics, Display Descriptive Statistics, and set variables to coin, because the coin variable is the variable we're interested in. The output will show up in your session window. You'll round your answers to 3 decimal places and type the mean and the standard deviation in the gray area of your template. Now remember, your results will be different than mine because I have a different data set than you do. For the next 2 questions, you're going to list some of the individual and cumulative probabilities you found at the beginning of the lab in question 1. So that work's pretty much already done. Let's take a look back at that worksheet. On my template, I want to focus on the column of 1/3 probability of success. So that's the only column in which I will look for values. You can either type your values or copy and paste them directly onto your lab answer template. You have 2 options on question number 4. You can add your probabilities directly from the chart using a calculator, or you can let Minitab do the work for you using the probability distribution plot like we learned in class. So let's review that process. To find the probability that x is greater than or equal to 1, you would click Graph, Probability Distribution Plot, View Probability, and then OK. Now remember, Your value of interest would be all the probabilities of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15, all of them added up together. So you could either add all those up one at a time from 1 to 15, or you can let Minitab give you that value. Once the new screen opens up, you'll need to select Binomial from the drop-down window. Enter 15 for the number of trials and 0.33 for event probability. Again, I know 1/3 has more 3's, but for this example, I'm just going to round it to 0.33. Since we want to know shaded area, we're going to click Shaded Area tab and tell Minitab that we want to know right tail. The reason we want to know right tail is because we want to know towards the right. We want to know greater than 1. We want to know from 1 to larger numbers. And on a number line, to go from 1 to 15 is from left to right. So then we're going to click OK. Notice how all the bars are shaded, including the 1. This means all of the probabilities were added to get 0.9975. The 1 was included. The 1, the 2, the 3, the 4, the 5, all the way up to the 15. Everything you see shaded in red was included in that total sum. Let's see how that is different from probability of x greater than 1. Notice that symbol is just greater, whereas the one we just did was greater than or equal to. In this case, we only want the values to be bigger than 1 and beyond. So we don't want to include 1 anymore in our total. We want to start with the values larger than 1. We can click the button to return to the previous menu options and simply change our x value to 2. We don't need to go through the entire process again. We just need to change our values where Minitab is doing our calculating. So use the button that will reopen the editor window and change the x value from where it is calculating from 1 to 2. Now remember, we're going to use 2 because now you don't want to include 1 in the total. You only want values bigger than 1, so the next value in the list would be 2. So after you've entered 2, click OK. See how now the shading starts at the bar above the 2 and goes to the right? That means that now we've started adding at 2 for the probability of 2. We've got the probability of 2, the probability of 3, the probability of 4, and so on, all the way up to 15. So your probability is 0.9794. So now we're asked to find the probability that x will be between 3 and 6. So this is the area between two values. But it's a little different. The 3 is not included, but the 6 is. See how the symbols are a little different? One has a line under it and the other does not. So go back to the editing option in Minitab and change your x value and shading option. Select the middle curve because you want between. Then enter your x values. On the left, you want to start at 4 because you need to be above the 3. Remember, it's not included. On the right, you want to end at and include 6. Once you've done that, click OK. See how now you have the bars 4, 5, and 6 shaded, but you don't have 3 shaded. That's because you didn't want 3 to be included. You only wanted above 3 and 6 included. So you have 4, 5, and 6 shaded. That means the probability for 4, the probability for 5, and the probability for 6 were added together to give you a cumulative probability of 0.5878. So the probability that you would have 4, 5, and 6 would be 0.5878. So I will continue on to find probability of x less than 0, probability of x less than or equal to 4, and probability of x less than 3 or greater than or equal to 6. I'm not sure what happened to the sound on the other video, but we'll just pick up right here. So to find the probability of x less than 3 or greater than or equal to 6, it's important to note that you're going to want to find each of those probabilities and then add them together. So make note that when you find less than 3, you're not going to include 3. And when you find greater than or equal to 6, you are going to include 6. So when you do less than 3, you're going to want to start at 2 and go to the left in the left tail, but then you want to start at 6 and go to the right tail. So this is how this would look. You'll do 2 different calculations there, and you will get 0.0833, and then when you do your right side to find the 6, you will get 0.3709. Adding those two together will give you the total probability for those 2 values or those 2 areas. And that's the answer that you want. So it's not just a single calculation there. You're going to have to do both of them. So now when we move on to the next part, we sort of come out of Minitab, and you can do some hand calculations, but fortunately these are pretty easy calculations. These formulas are just some multiplication and then maybe taking a square root. The binomial distribution uses the formula n times p and n times p times q square root for the standard deviation and the mean, and the formulas are given right here for you. So all you need to do is take the information out of the problem in order to calculate the mean and the standard deviation for each. So you are instructed in number 5 to calculate the mean and standard deviation for the binomial distribution with the probability of success being 1/3 and n equal 15. You do need to show your work or explain how your answer was calculated. Use the formulas to do the hand calculations. So it's easier just to show your work. So in the first part, the mean is going to be equal to 5 because n is 15 and your probability is 1/3. And 15 times 1/3 is equal to 5. Now remember, Q is just the complement of P. So 1 minus p is going to be 1 minus 1/3, and that leaves us with 2/3. So now we have the total of probability, which is always 1 or 100%. So we have 2/3 and 1/3. We have p, we have q, and we have n. So we can find the standard deviation. So the square root of n times p times q will give us our standard deviation. And that is just a calculator function. You can I would do the multiplication first. I would do 15 times 1/3 times 2/3 and get that answer, and then take the square root. If you have trouble finding that square root key, you can also do a little trick and raise it to the 1/2 power. It's the same thing as taking a square root. So your standard deviation there is 1.83. You'll do the exact same type of calculation in number 6. In number 6, we're going to change our probability of success to 1/6. Our n remains 15. So our mean will be equal to 15 times 1/6. When we do that arithmetic, we get a mean equal to 15 over 6, which divides out or multiplies out to be 2.5. So again, with our standard deviation, we need to do a little bit of quick arithmetic here to get our q. So q is still equal to 1 minus p. So 1 minus 1/6 will give us our q. 1 minus 1/6. Q is equal to 5/6. So now we have everything we need to calculate standard deviation. So the square root of 15 times 1/6 times 5/6. And again, I would do the multiplication first in my calculator and then take the square root. That makes sure that the order of operations is followed, and you'll get a standard deviation of 1.44. Now, in number 6, you're asked to write a short paragraph of comparisons of these statistics. So what you're asked to do is compare the results that you got in question number 6 to the results that you get in question number 5. So if you want to just take a look at your standard deviation and your mean and compare them in number 5 and number 6 and see what happened when you had a larger probability versus a smaller probability. Look at what happened to your mean and your standard deviation. Did they get larger or did they get smaller? And see what happened and make a conjecture as to why you think that happened. What do you think happened? Did the larger probability have an effect on your mean and your standard deviation? So again, on number 7, you're going to want to do the same type of calculation. So 15 times 2/3 will give us our mean. 15 times 2/3 would be 10, because we would have 30 over 3 when we did that multiplication. Our q can be found again by 1 minus 2/3. So 1 minus p is 1 minus 2/3. And that gives us 1/3. So our square root of 15 times 2/3 times 1/3 gives us the standard deviation. Again, do all of your multiplication first and then take the square root to ensure that your calculator is following order of operations. And we get a standard deviation of 1.83. So again, write your comparison. Notice what happened as your probability goes up. Look what happens to your mean and your standard deviation. So you can write that comparison. You can make a conjecture as to the impact of probability on your mean and standard deviation. Now, using all 4 properties of the binomial experiment, explain in a short paragraph why the coin variable from the class survey represents a binomial distribution. Now remember, there are 4 properties of the binomial experiment. You need to write this up using all 4 properties, and you should explain how each one of the 4 properties are met using the coin variable. So you should list property 1 and which part of the coin experiment meets that property. Property 2, which part of the experiment meets that property. And so you should have 4 parts to that answer. So make sure that you write each of the 4 characteristics. If you don't have all 4, then you won't get all 4 points for that question. So down to question number 9. You're going to use each of your answers that you got. You're going to compare your statistics for the coin variable, where each of the 20 students flipped a coin 10 times, right? So in that particular one, there were 20 students who actually stood there and flipped a coin, all right? So in that case, they had a mean of 5 and a standard deviation of 1.435. So then in question number 5, instead of actually having someone stand there and flip a coin, what we did was we took theoretical data, what we would expect to happen. There wasn't anyone actually doing an experiment. It was just theory. It was what we would expect to see if we set a probability at a particular value and we set n at a particular value. So nothing was actually happening. We just used values that we wanted to see what would happen numerically, in theory, what we would expect to see. And we calculated mean and standard deviation, and we got 5 and 1.83. So in one case, we had real data. We had people actually performing an experiment. And in another case, we just used theory, and we wanted to see what would actually happen. So that was what our comparison was. So we just took a look at what happened in real data, and we took a look at what would happen in theory, and we compared those. So that's kind of your comparison in this case. We wanted to see what would happen when we actually performed an experiment and what would happen when we used theoretical data. So you can write that up in your own words, how you think that should sound, but essentially that's the explanation for that problem. Again, your numbers should be different. You don't want to type things up verbatim as I did, but your values will be different. And that's how yours should end up looking.